Hey guys, this is me going over our study guide for our next unit test, which will be on interest rates, simple and compound, scatter plots, and possibly a few volume and surface area problems. So let's start at the top. There are two kinds of interest rates we talk about: simple interest, which is I equals PRT for just the interest. If you want to get the total amount they earned, it's going to be I plus the principal. So you would take the interest you earned, add it to the principal. Then there is compound interest, which is A equals P 1 plus R to the T power. That's the total amount of money in the account. If you want to know what just the interest is, you would take the total money in the account and subtract the principal. So I put reminder, simple interest is just the interest earned, and compound interest is the total money. Pay attention to problems where you have both simple and compound. So starting with problem number 1. This is for 1 through 2, solve for simple interest and total money after interest. So $5,000 at 10% for 5 years. So that's going to be I equals PRT. P is our principal, R is our rate, T is our time. So I plug that in, that's going to be 5,000 times my rate, which is 10%, but you got to move the decimal 2 times. So that's 0.10 times my time, which is 5 years. Okay, so in your calculator, you're going to type 5,000 times 0.10 times 5, and you get 2,500. So the interest earned is 2,500. The total money, remember, is going to be that interest earned, so that 2,500 plus the amount we start with, plus our principal, which is 5,000. So that's going to be 7,500 for the total amount in the account, the total money earned. So next is $2,000 at 12% for 3 years. So again, our formula is, I'm focusing my camera here. Here we go. What am I doing? That's better. So I equals PRT. So it's going to be 2,000 times our rate is 12%, which is going to be 0.12 times 3. So 2,000 times 0.12 times 3, which is equal to 720. So the interest is 720. The total money is going to be that 720 plus our principal, which is 2,000, which equals 2,720. Okay, problems 3 and 4. Solve for total earned compounded and just interest earned. So our first problem, our formula for compound interest, by the way, is A equals P 1 plus R to the T power. So it has all the same variables, P, R, and T. We're just in different formula. So I'm going to plug this in, $1,000, 1 plus 0.08, because if I move the decimal 2 times, I have 0.08 to the 5th power. Okay, so we're going to type that in our calculator. Figure that out. So it's going to be 1,000 parentheses 1 plus 0.08. And then you're going to use this button right here that looks like an upside down letter V. And that's going to be to the 5th power. Let's see if you can see that better. Kind of a glare on it. And hit enter. And you get this number. $1,469.33. So this number right here is the complete total money either earned or owed, depending on what, if it's a borrowing problem or a saving problem. To get just the interest, you're going to take that money and you're going to subtract the principal, which in this case was 1,000. So just the interest earned was $469.33. Okay, let's try another one. $2,000 at 12% for 3 years. A equals 2,000, 1 plus 0.12 to the 3rd power. And then we're going to type that in our calculator, 2,000 1 plus 0.12 to the third power, and you get 2,809.86. So A equals, that's all of our money together, 2,809.86. Interest earned is we're going to take that total money in the account and we're going to subtract the principal, which eats us up with $809.86 in just interest. All right, Richard invested $15,000 in an account that pays 5% simple interest. Richard will not make any additional deposits or withdrawals. How much interest will Richard earn on his investment at the end of 10 years? So we know we're using this simple interest formula because that's what the problem tells us. So make sure you use the simple interest formula on your formula chart. That's going to be principal, which is 15,000 times our rate, which is 0.05%, because we moved the decimal twice, times T, which is time, and that's 10 years. So I'm going to go ahead and type that in my calculator. 15,000 times 0.05 times 10, and you get 7,500. So the problem asks how much interest will he have. So remember, the way the simple interest formula is built is that this answer, I, stands for interest. So this answer already is the interest. I don't have to do anything to it. Okay. Do not add the principal. That's only for if we're solving for the total money. So you don't need to add the principal. You don't need to subtract anything. 7,500 is the interest. We're done with the problem. All right. Next page. Marcia deposited $3,150 into account. She made no additional deposits or withdrawals. Marcia earned 3.5% annual simple interest on money in the account. What was the balance in dollars in her account at the end of 5 years? So we know we're doing simple. So we're going to do I equals PRT, which is going to be 3,150 times 0.035 times 5. I know it's 0.035 because I moved that 2 times. A 0 right here. So 3,150 times 0.035 times 5, and you get this number, 551.25. But it asks for the balance in the account. Balance is how much total money you have in the account. This number is just the interest earned. It's not the balance in the account. So to get the balance in the account, we have to add what we started with, which is 3,150. So we're going to add that. And you end up with 3,701.25. So that's how much total money this girl has in her account now, with the interest and the money she started with. All right, number 7. This is probably the most difficult one you're going to have on your test, but you guys can do it. I believe in you. Clark deposited $2,100 into 2 savings accounts. Account 1 earns 3% annual simple interest. Account 2 earns 3% interest compounded annually. If Clark does not make any additional deposits or withdrawals, what is the sum of the balances in account 1 and account 2 at the end of 4 years? So I like to split my paper in half. Over here, I'm going to have simple interest. And over here, I'm going to have compound interest. Okay. So for a simple interest problem, so we start with 2,100 times my rate is 3%, so 0.03 times 4 years. And that's going to equal to, type that in my calculator, 252. And on this side, we have 2,100, 1 plus 0.03 to the 4th power. So it's going to be 2,100, parentheses 1 plus 0.03 to the 4th power. And that is 2,363.57. Okay, there's a reason that this number is so much bigger than this number. Remember, simple interest is just the interest. So that 252, that's only the interest earned. This amount of money in the compound interest, that's all the money. That's the interest and the 2,100 you start with. So going back to the problem, it says, what is the sum of the balances? So it wants the total money for each, and sum means add. So it means we're going to add them together. So I have the total money here, so we're good there. But I don't have the total money here. I still have to add that principal to get the total amount. The total amount on this side is going to be 2352. And now that I have both of these numbers, now I can add them together. So add 2352 to both sides, and you end up with, I'm going to write over here, 4,700, 715. That looks messy. We'll start that over. 4,715 and 57 cents. And that's how much total money is the sum of the balances in the two accounts. Number 8, switching up a little bit. The scatter plot below shows the relationship between the length of a long distance phone call and the cost of the phone call. Based on the line of best fit for the scatter plot, which the following accounts is closest to the cost of a 120-minute phone call. So in this axis, we have the cost of the call. So in this axis, we must have the minutes. And there is no line of best fit, so we need to draw one. Remember, a line of best fit is a line that just goes as best you can through the middle of the points. Use the edge of your paper or the edge of your calculator or something if you need to visualize it on your computer screen. So looking here, we have 20, 40, 60, 80, 100. 120 would be out here, like past the graph. So because it's out there past the graph, what we're going to do is we're going to look at 60 minutes. And we figure out how much 60 minutes is, then we can double it and figure out how much 120 minutes is. So we're going to go 60 minutes. We're going to go straight up and straight over. So 60 minutes was $6. That means 120 minutes must be $12. Number 9. A group of friends recorded the time it took to ride their bikes around the park. The scatter plot shows the results with the line of best fits. Line of best fit's already been drawn in this one. Using line of best fit, what is closest to the number of minutes it would take to complete 9 laps? So we're going to look at our axes and see which one is 9 laps. And laps is this one. If laps was over here, we would start on this side. But laps is here. 9 laps is right here. All right, so our line does not keep going. But what we can do, I'm going to use a sticky note for this. And I'm just going to continue this line out so that it is further. There we go. So 9, so we're going to travel straight up to the line and straight over. So it is B5. 9 straight up, straight over. That's how we get that one. Number 10, everybody's favorite, including my own. The list below shows the number of hot dogs each contestant ate at last year's Nathan's hot dog competition. What is the mean absolute deviation of hot dogs in the list? So I have 1, 2, 3, 4, 5 numbers. So there were 3 steps to mean absolute deviation. Step number 1 was find the mean. Step number 2 was subtract. And step number 3 was find the mean again. So the very first thing I need to do is find the mean, which means we are going to add up those numbers and then divide by how many numbers there are. And since there's 5 numbers, we're going to divide by 5. So 76 plus 71 plus 62 plus 72 plus 41. And that equals 322. And then we're going to divide that by 5. So that means that our mean is 64.4. So step number 1 is done. Step number 2, we're going to take every single one of these 5 numbers and we're going to subtract it from the mean. Meaning I'm going to do 76 minus 64.4. 71 minus 64.4. 62 minus 64.4. 72 minus 64.4. And 41 minus 64.4. Now, guys, if you flip-flop these and you did like 64.4 minus 76, it's fine. You'll get the same answer in the end because we are taking the absolute value of these numbers, which means we don't need to worry about the negative, right? We're only using the positive answers. So 76 minus 64.4 is 11.6. 71 minus 64.4 is 6.6. 62 minus 64.4 is negative 2.4, but we're using the absolute value. So the absolute value of negative 2.4 is just positive 2.4. 72 minus 64.4 is 7.6. And then lastly, this one over here, 41 minus 64.4 is 23.4. It's actually negative 23.4, but remember, we're using the absolute values, so just positive. All right, so step number 2, subtract. Done. Now we have 5 new numbers. This one, this one, this one, this one, and this one. So what we're going to do is we're going to find the mean of those 5 new numbers. So I have 11.6 plus 6.6 plus 2.4 plus 7.6 plus 23.4. And again, we're going to divide that by 5 because there's 5 numbers. And so the mean is 10.32. Found the mean here. And this is your final answer. So just a refresh. We found the mean, which was 64.4. Then we subtracted every single number from the mean, or found the difference between the numbers and the means, which means we subtract. Then we took those 5 new numbers and we found the mean again, and that's your final answer. All right, a cone has a diameter of 12 centimeters. Draw myself a cone. Good enough. All right, diameter of 12 centimeters and a height of 8 centimeters. What is the volume of the cone? So we're going to grab that star formula chart and look for the volume of a cone, which is this, 1/3 big B H. Okay, big B, you need to know what big B stands for, is the area of the base. And so you think to yourself, all right, well then what shape is the base of a cone? The base is a circle. So then go back to the star formula chart, and the area of a circle is pi r squared. H stands for height, which is 8. So 1/3 pi r squared times 8 is what we're going to be typing in. R stands for radius. If you're looking at this base, it looks like this, where the diameter is 12. R stands for radius, which means we cannot use diameter. But luckily, we can use diameter to find radius, because radius is half the diameter, and half of 12 is 6. So we're going to type 1/3 pi 6 squared times 8 into your calculator. Another option to type in your calculator is pi 6 squared times 8 divided by 3, because those are the same thing. Okay, remember how we talked about how a cone is 1/3 the size of a cylinder? That's where that 1/3 comes from. So I'm going to type pi 6 squared times 8, and then divide that by 3. And you end up with 301.59. This would be centimeters cubed, because we're talking about volume. All right, so either of these work if you want to use the 1/3, or I think I like this one better. Pi r squared times h divided by 3. Last problem, number 12. A cylinder has a diameter of 8 feet and a height of 9 feet. What is the total surface area of the cylinder? So we're going to go to that handy dandy star formula chart, find total surface area. And total surface area of a cylinder is 2 pi RH plus 2 pi r squared. So R stands for radius. If I don't have the radius, I have the diameter. We just talked about how you can use, oh gosh, it went out of focus. There we go. We just talked about how you can use diameter to find radius, because radius is half the diameter. So 2 pi times 4, because that's what half of 8 is, times our height, which is 9, plus 2 pi 4 squared. And you can type that whole entire thing into your calculator. Let me clear this out. 2 pi 4 times 9 plus 2 pi 4 squared. So you can see I just typed that whole thing in there all at once. You hit enter, and the answer is 326.726, and this would be feet squared for the surface area. So I don't know if you noticed, but in both of these problems, I gave you diameter instead of radius. So we've done that now 2 times. So my expectation is that you know how to use radius when the problem gives you diameter. I hope that this was helpful to you because I think you guys can do really good on the test. But please email me if you have any questions.